in this section we are going to see about design thinking concept based on Fourier series. So what do you mean by design thinking? So here we have 5 stages. One is empathy, second one is define, and the third one is ideate, fourth one is prototype, and the last one is testing. So empathy part is going to define by Chiteshwar.
Empathy, imagine you have a complicated, irregular sound wave or a repeating pattern on the screen. Instead of the declining with the complex, unpredictable waveforms of the Fourier series, says we can repeat the exact same wave by the adding together by the patch of the simple waves. We have a stretching frequencies.
Let me explain about define. We need a method to represent any periodic function using simple trigonometric components so that analyzing, filtering and signal reconstructions becomes possible. Mathematical transcription is given a periodic function f of x can we express it as a sum of sines and cosines with specific coefficients.
So Fourier series is nothing but a combination of sine and cosine waves. So let us consider a mathematical problem and analyze the ideate part. So that will be done by Darshan.
So here we have the sine equation, that is f of x is equal to pi minus x by 2 with the limit of 0 to 2 pi. For Fourier series we have the formula for 0 to 2 pi. F of x is equal to a0 by 2 summation n from 1 to infinity an sin nx and summation n from 1 to infinity bn cos nx. So this is the formula for the limit 0 to 2 pi. So
an cos nx and bn sin nx.
And we need to calculate the three terms, that is a0, an and bn. For a0 we have a formula, that is 1 by pi integral of 0 to 2 pi f of x dx. This is the formula for a0, and similarly for an we have a formula, right? This is 1 by pi say 0 to 2 pi f of x, and the term we are having right here, this is cos mx and dx. For bn we have a formula, that is 1 by pi integral of 0 to 2 pi, and the term we are having is f of x, that is the sin nx, that is sin nx dx. These are the three major formulas to find a0, an and bn. So let me start by calculating the value a0. So to calculate a0, the formula is 1 by pi 0 to 2 pi f of x dx. So this 1 by pi 0 to 2 pi, f of x is nothing but the given value here, that is pi minus x by 2. So let me substitute here pi minus x by 2 into dx. So we have the term right, pi by 2 minus x by 2. So let me take the 1 by 2 outside. So this became 1 by 2 pi and pi minus x dx. So on the integral of pi minus x, we get the answer is the pi is the constant. So 1 by 2 pi, integrating we get pi x. That is, in integration the constant term will be added with x, and on integration with x, that is, it becomes as x squared by 2, and the limit is 0 to 2 pi. So let me substitute the limit only in x, that is 2 pi square. On substituting x here, it will become 4 pi square by 2. Let me take the LCM 1 by 2 pi. The LCM became 4 pi square minus 4 pi square by 2. The total term became 0. That is, the value of a0 is 0. The similar way we can use for an and bn. So the formula for an is equal to 1 by pi integral of 0 to 2 pi and f of x cos nx dx, that is 1 by pi integral of 0 to 2 pi. The f of x value is pi minus x by 2 and this cos nx dx. So let me take the value 1 by 2 outside, that is a constant value. So 1 by 2 pi, 0 to 2 pi, pi minus x cos mx dx. So on this step we need to calculate with the formula that is known as Bernoulli's formula. So Bernoulli's formula is nothing but f of x is equal to u v1 minus u dash v2 plus u double dash v3. So the u term is the differentiation term and v1 is the integration term. By using this method, we get the value for an is 0 and bn is minus 1 by n. By using this formula, we get the two values as an is 0 and bn is minus 1 by n. So we got the terms as a0, an and bn. In the final, we should substitute in the formula, that is an also 0, remaining is bn, which will be substituted as summation n is equal to 1 from infinity minus 1 by n and bn is sin nx. This is the Fourier series for the sine wave. Thank you.